Hello everyone, I'll explain problem C, banknotes. Now what does the problem say? Uh, you have n different types of banknotes and the ith banknote has this value, 10 ki power ai. So for example, if you can have banknotes of 100 and 1000 and 10,000, or let's say 1 lakh. So each note has a value of either 100,000 or 100,000. What you want to do is you want to find the minimum number n, which cannot be formed by taking k notes out of this set, any combination of those k notes. Uh, for example, if you are taking 1 rupee coins A times, 100 rupee coins B time, 1000 rupees coins C time, and this D times. So the first condition is that A plus B plus C plus D should be less than equal to like you have to find a number n such that a plus c plus d is less than equal to k, and second is 1 into a, that is their sum, 100 into b, is not equal to n, and you have to find the smallest such n. That is, no matter whatever combination of a b c d you take with this particular constraint, you can never get the value n, and you want the smallest such number. For example, a very small example, if you have only, let's say, 1 rupee coins or notes, so and k is given to you as 5, that is, you can pick at most 5 1 rupee notes, and you have to find what's the smallest number n which you cannot make, which you cannot. So uh, the answer in this case is 6. How? Because you can take at most 5 1 rupee coins, so your sum would be 5, and any value greater than 5 you can never form. So 6, 7, 8, all of these are valid answers. 6 is the smallest, so we'll print 6. So how do you do it? Let's first try to solve something else, and then we'll move on to the solution. Suppose you are given this number and you want to obtain this number as a sum of 100 and 10,000. That is, these are basically notes having value 100 and 10,000. So if you take you basically, if you take one a types of a quantity of 1 rupee notes, b quantity of 100, and c quantity of 10,000, then a plus b plus c should be minimum, and 1 into a plus 100 into b plus 10,000 into c should be this value. So how would you solve this? Well, you can solve it in a greedy fashion. We know that, okay, 10,000 gives us the, we need to minimize a plus b plus c, right? So we will try to first pick that coin or that note which gives us the maximum value, because no matter whatever type of note we pick, we would, if we pick like one rupee note or 100 rupee note, our total count of notes that we are picking will always increase by 1, but the value which we are getting um, differs on the type of note we pick. So we want to first pick the note with the maximum value, that is 10,000. And how many such notes we can pick? Basically 28612472 divided by 10,000, which is 28612. So these many notes of 10,000 rupees we should take. Then what's the remaining amount left? It's 4748. If you pick this many 10,000 notes, then this much value is remaining, which you have to form using these uh, two notes. Now you can obviously not take a 10,000 rupee note because your value is less than 10,000. So you'll pick some 100 rupee notes. And how many of them you will pick? You will pick 47. And the remaining notes are 1 rupee notes. So you will pick, you have 48 value remaining, 40 divided by 1, which is 40. So basically you add these three, and this is the minimum value of a plus b plus c, so that you can get this sum. Now we can formulate the problem statement uh, in a similar fashion. What we want is, we want a number n such that the minimum value of a plus b plus c plus d, like as many nodes as you have, to form n is greater than k. So you need at least k plus 1 or more nodes to get this value, right? Okay, now one more thing. When I was talking about uh, how many nodes of 10,000 we need, how many nodes of 100 we need, how many nodes of 1 we need. So there's a very interesting visualization which we can do. Basically what you do is, you divide this number into three parts. Why three parts? Because there are three numbers. So what is the first part? You first look at the maximum node. It has four zeros, right? So 1, 2, 3, 4. Skip four decimal places, and everything from there till the end is your one segment. Now look at the next node. There are two zeros. So in this remaining part, you skip two decimal places, and everything from here to this is your second portion, and the third portion is this. And if you remember, these were the number of nodes that we required. So it's very simple. It should be intuitive why this is working. These are basically the number of 10,000 rupee notes that we require. These are 47 are the number of 100 rupee notes, and 48 are the number of 1 rupee note. And this is for the minimum value of a plus b plus c. Right. Now you can also take some other examples. Suppose you have number 3, 2, 4, 6, 1, 5, and you have suppose 1, 10, and 10,000. So you 1, 10, and 1,000. Let's take these three. So how would you divide in segments? The first segment would be, skip the first three decimal places, take everything from here till here. Then go to the next segment, skip one decimal place because there is 1 0, and take this portion, and then this. So this is 324 plus 61 plus 5 is the minimum number of um, nodes that you need. Okay, so we will use this concept of making partitions to solve our problem. So I'll take an example in the sample test case, and I'll show how you solve the problem using the algorithm which I tell you. Starting off, I will consider my answer to have at most 19 digits. I think 18 digits is also fine, but to be safe, I assume that okay, in the worst case scenario, the answer can be of 19 digits. Why did I choose that? Because it's given that k is at most 10 to the power 9, and the maximum value of an is also 9. So if an is 9, then that means the particular coin would have 10 to the power 9 value, and you have k as 10 to the power 9, so it would be 10 to the power 18. So I just added 1 and I took 19 digits. Okay. Now what to do is, in the sample test case, you were given as n as 3. That means you had 3 coins of these powers. So 10 ki power 0, 10 power 1, and 10 ki power 3. And your k value of k was 255. So I'll go in reverse fashion, and I will make the segments first. So I'll go to 10 to the power 3 first. I'll say, okay, how many digits do I have currently? I have 19 digits. Fine. What is the power? 3. So I'll skip basically the first 3 digits. So I'll go from the 3 plus 1th, that is 4th digit, to the 19th digit, and I'll make a segment. So this is my first segment. Then I will update my value. Now I don't have 19 remaining digits. I have only 3 remaining digits. So I have only 3 remaining digits. Then I go to the next number. I say, okay, I have 3 remaining digits. What is its power? Its power is 1. So everything from 1 plus 1 to 3 is going to be my second segment. This is one based indexing. 1, 2, 3, 4. And for the last, I have only one digit remaining, and everything from 0 plus 1 to 1 is going to be my this segment. Okay. So this corresponds to 10 to the power 3, this corresponds to 10 to the power 1, and this corresponds to 10 to the power 0. Now we want the minimum number, and we also want that the total number of nodes we require is more than 255. So I'll go segment by segment. I'll go to the first segment of 10 to the power 0. Why I'm going to this segment? Because it has the least value. And suppose if I give this segment 8 digits, uh, basically if I am trying to construct my number. Like in this example, I am trying to construct my number. So if I give it 8 here, that means in order to reach, in order to get this 8, I would have to sacrifice 8 nodes. But okay, so how many should I put here? I should not put 8, I should put 9, because I want to maximize this value. Why I'm maximizing this value? Because uh, I want the lower segments to take as many k values as they can, as many contribution of k as they can. So basically I'll put 9 here. Then I go to 10 to the power 1. How many digits I have here? I have 2 digits here. And so k is now 254 basically, because I have, sorry, not 254. K was initially 255. I put 9 here. That means in order to get this 9, I would have to use 9 10 to the power 0 nodes. So now I have to fill the boxes in such a way that the updated value of k is 255 minus 9, and I have to fill the remaining boxes as such. So 255 minus 9 is 246. Now I go to this segment. There are 2 digits here, so I can fill at max 99. But I'll check, is the value of 246 greater than 99 or less than 99? In this case, it is greater than 99. So 246 minus 99, which is 147. So I'll remove 99 more from this. That means in order to get this 990 basically, since there would be a 0 afterwards as well. So in order to get 990, I would have to use 99 10 to the power 1 coins. That's what it means. So it's 147. Now I'm at this part, and I want to, my remaining value of k is 147. So I'll basically find, okay, what's the maximum value I can get here. It's going to be a very large value, and this value is obviously greater than 147. So what I will do is, if this is greater than 147, I will put 148 here and finish. So you'll have a sequence of 9s, and then you'll have, if the value is greater than the remaining value of k, then you will add a k plus 1. You see, you cannot put a 147 here because you can obtain 147,999 using exactly 255 coins. So you have to put 148. One last thing. So this is how you will do. You will break it into segments. You will go into each segment. You will try to find the number of digits in that segment, and then you can have a maximum value of 9999, then which is 9999, which will go to the number of digits in that segment. and if that value is greater than k, then print k plus 1, and then the other nines which you had already placed. Otherwise, if it is less than k, then fill that entire region with nines and move to the next region. Okay. One last case here would be if you had something like, pick a new page. If you had the same example, suppose you had uh, two digits here, one and a lot of digits here, and your k was 999. So this is a case where you will completely exhaust your case. I'll show you what I mean. So you'll first go to this segment. You will add one 9. Now, how many nines do you have? Okay, not 99 would be, one second. If you have something 99 plus 9, this is 108. Yeah, if you have 108, then what you will do? So you'll go here, you will exhaust your nines. You will have 99 remaining. You go here, you fill 99 here, you have 0 remaining. You go here. So what do you do now? This is an edge case, and in such a case, you have to just add a 1 and then print the entire thing. Okay, that's how you solve the problem. I'm sorry if it was confusing, um, but I hope you understood the gist of it, how the partitioning works, and then why do you like it's very obvious why you are starting to fill from here. So I was trying to explain why you do that, but it's a very obvious thing. I hope you understand why I'm filling from this end, not from this end. Why I'm filling a 9 here. Because I want to exhaust as many coins as I can, and I want to use the least uh, value nodes. Okay, I'll just quickly show you the algorithm. So this part of the code, basically, I had 19 digits, like I said. Then I'm making the segments, and then after doing this, I'll basically get an array having all the segments and how many digits are in those segments. And then I'll iterate over each segment. If my value of k is 0, like I told you in that edge case, I'll print 1 and the remaining string which I had already created. Otherwise, if this is basically a way to get as 9999. If the number of nines in that region, so if the segment length is 2, then you would have 99. So if 99 is greater than k, what you do is you print k plus 1 and you print the string that you had already created. Otherwise, you remove from k 99, or the number of nines, like whatever value you get after filling that segment with all nines, and you also append that part to the string, and then finally you print the answer. That's all for this video. Thank you for watching. Bye.